When a fluid is flowing steadily in a long straight pipe of uniform diameter, the flow pattern, as indicated by the velocity distribution across the pipe diameter, will assume a certain characteristic form. Any impediment in the pipe, which changes the direction of the whole stream, or even part of it, will alter the characteristic flow pattern and create turbulence, causing an energy loss greater than that normally accompanying flow in straight pipe. Take a look at the following schematic. Because valves and fittings in a pipeline disturb the flow pattern, they produce an additional pressure drop, as depicted here. So if we compare P3, the downstream pressure in the presence of the valve, to P2, the downstream pressure without the valve, we will get the following. P3 will be lower than P2 due to loss of pressure produced by the valve. The loss of pressure produced by a valve is the combination of three separate components. The first component is the pressure drop within the valve itself, referred to as delta P. The second component is the pressure drop in the upstream piping in excess of that, which would normally occur if there were no valve in the line. This effect is small. And finally, the third component is the pressure drop in the downstream pipe in excess of that, which would normally occur if there were no valve in the line. This effect, however, may be comparatively large. From the experimental point of view, it is difficult to measure the three items separately. Their combined effect is the desired quantity, and this can be accurately measured by well-known methods. Take a look at the following piping system. It shows two sections of a pipeline of the same diameter and length. The upper section contains a globe valve. If the pressure drops, delta P1 and delta P2 were measured between the points as indicated here, it would be found that delta P1 is greater than delta P2. Actually, the loss chargeable to a valve of length d is delta P minus the loss in a section of pipe of length A plus B. The losses are expressed in terms of resistance coefficient, referred to in this course as K. The resistance coefficients of various valves and fittings are given in the following figures. The losses include the loss due to the length of the valve or fitting. These diagrams are available in the downloadable resources section. Please download these figures and have them ready, as we will need them for the practice session further ahead.